This is the tutorial video for Lesson 6.3 Domain and Range. By the end of this lesson, you will be able to understand the meaning of domain and range and express them in a variety of ways. First, let's look at what domain and range means. The domain is the set of all possible values for the independent variable in a relation. So basically, you're looking for all of the x values that are included in a relation. These can be the first values listed in the ordered pairs for the relation. They could be in the first column of the table of values if you have a table of values with x, comma, y. They can also be the values plotted along the horizontal axis in a graph. So you're looking at your x-axis values. The range is all the possible values of the dependent variable as the independent variable takes on its possible values. So, as your x values are changing, what are your y values? Your y values are the range values in the relation. So, y values are usually the second values in the ordered pairs, or the values in the second column of the table of values. Also, plotted on the vertical axis, you have your y values in a graph. Let's have a look at example 1. In part A, what values of x and y are included in each graph? So if we've graphed our line here, y equals 1/2 x plus 2, we want to see what values of x are included in this graph. So I'm going to do this in blue. What you do is you have to imagine every point on this graph. So there's a whole bunch of points, right, and everything in between. And you want to know what are the x values of those points. Well, you want to look down from those values at your x-axis. So right there. And decide what value, or see which values of x are included. So we have, every x value along this line. So all those positives here, all these negatives along here are included. Also, the actual red line goes to the left and to the right forever because there's arrows on the end of it. So as this red line keeps going, let's go to the negatives, we still are including all these x values straight to negative infinity, and all the x values straight to positive infinity are included. So all values of x from negative infinity to positive infinity are included. Now let's look at y. For the y values, I'm going to use a green, so they stand out differently. Every one of these points on the line that we were talking about with the x values also has a y value. So from these points, you want to look over to the y-axis and see what their y values are. Now because this line keeps going down forever, and it keeps going up forever, we are still going to go from negative infinity to positive infinity on the y-axis. So the range of this graph is also from negative infinity to positive infinity in terms of the y values. We're going to look at the official symbolic way of writing domain and range in the next example. But first of all, we're just practicing how to identify them. So looking at example B, let's identify the x values included. So again, imagine a whole bunch of points on this line. What are the x values of these points? Look down from all of those points to the x-axis. And it looks like all of these points are included, and everything in between, every x value is included in this graph. And again, it goes to negative infinity and positive infinity on the x-axis, so left to right. So again, we have all values of x from negative infinity to positive infinity are included. However, this time our y values are a little different. Each of these points, if we look at the y-axis this time, every single point on this line has a y value of 2. So the y values included in this graph is only y equals 2 because the graph goes through that and no other y values would be included on this graph. You could not go anywhere else on the y-axis and go across and find the graph anywhere. So it's only at going through y equals 2. In example C, we have a vertical line that goes through the point x equals 3. So if we again imagine a whole bunch of points on this line and we look at the x values in each of these points, we notice that they all have an x value of 3. Therefore, the x values included in this graph are only x equals 3. There are no other x values that can be found on this graph, on any of the points. And then we look at our y values to determine the range of the graph. The range is the vertical points. And for each of these points, we have y values that are different. And the graph goes down to negative infinity on the y-axis and up to positive infinity. So the y values included are all values of y from negative infinity to positive infinity, because the graph goes up and down forever. In example D, we have just a graph of points. So this is discrete data. So for each point, we want to look at what x value they have. So this one has an x value of -1, and then we have 0, +1, +2, +3. When we just have a few x values like that, we actually only list the specific x values included. So x equals -1, 0, 1, 2, and 3, and use commas in between them. For the y values, again, there's only specific y values included, so we look at the points on the graph and across to the y-axis. And those are the y values included. The only values are in the points. So the y values from the points are 0, 1, 2, 3, and 4, looking at the y-axis. And that's the range of this graph, discrete data. For example E, we have a line, but it stops at certain points, so it doesn't go forever in both directions or any direction. The x values included, we want to look at the lowest x value first. So we look at the left side of the line, and we go up, and we see that our lowest x value possible on the line is -3. So the x values are going from x equals -3 up to the highest x value. So we look at the right side of the graph and go see what its x value is, and it's +3. So from x equals -3 to x equals +3, and every value in between, because the graph is a solid line and they all have an x value, anywhere from -3 to +3. The y values, we do something similar. We look at the lowest y value first. So from the lowest point on the graph, we look at what its y value is. And it is -3 as well. So y equals -3, and it goes up all the way, they're all included, all the way to the highest y value of +3. When you're looking at these values, make sure you're looking for the y values for the range and the x values for the domain. Now that we have learned how to identify the domain and range values on a graph, we need to learn how to write them down in a variety of ways. The first way that we can write down domain and range is just using a word description. This is a detailed description of the values included, and you just write out in a sentence form what the domain and the range are. So a couple examples: the domain is the set of all real numbers between 1 and 10 inclusive. This all real numbers means any number, decimals, rational, irrational, it's all included, but between two numbers. And inclusive means that you include the endpoints. If it said exclusive, you wouldn't actually include the endpoints, it would just be every number up to but not including them. An example of range in words is the set of all real numbers greater than 20. And when you have a greater than 20, it would be the greater than sign followed by the 20 and whatever variable you had in front of that. Let's scroll down here. The number line is another way to express domain and range. And what you do is you start by drawing a number line with your scale. Then you draw the endpoints, if there are any, using an open circle if the endpoint is not included, and a closed circle if it is. So an open circle is just basically a circle not shaded in, and a closed circle is a shaded in circle. Then once you have your endpoints or your circles, you can draw a line in the appropriate place according to the endpoints and what values are included. If we look at the examples from the first, like the word examples, we're going to put those on a number line. So the domain example was the set of all real numbers between 1 and 10 inclusive. So we're going to start by drawing our number line, labeling it with a few values here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we have our scale established. Each tick goes up and down by 1. Then we're going to draw in our closed circles because our endpoints were included. Draw a closed circle at 1 and a closed circle at 10. And then, because the domain was all the real numbers between those two numbers, we draw a nice thick line in between them to show that that's where any solution could be found, is in between those two values. When you have the range, any numbers greater than 20, and we want to draw that on a number line, start with 20, 25, say. We draw an open circle because it's only values greater than 20. It's not values greater than or equal to 20. And because it's everything above that, we just start with our thick line and we draw a nice big arrow because it goes up every value right up to positive infinity. It goes up forever. Would be included on the number line. If you have discrete values, you can still plot these on a number line. And how you do that is you plot each number, a dot on each included value. So our included values are -2, so we'll have a dot there. It's definitely included, so we use a closed circle. A dot at 0, at 4, at 8, and at 10. And that discrete value just shows that just those values are included. A third way to write domain and range is to use a list. And this is especially useful with discrete data because there's only a few numbers usually in the set. If a number occurs more than once, you only need to list it one time. So that's an important point. In the example here, we have a relation of 4 coordinates, 4 points here. The domain is all of the x values included in this relation. So when we're writing it as a list, we write a curly bracket, then all the x values just listed with commas in between. So 0, 1, 3, 5. And then we close it with a curly bracket. That's the domain. The range is all the y values. So we had a 0, a 5, a 7, and a 7. Because there's 2 7s, we don't list them twice, we only list them once. So all the y values included are 0, 5, and 7. And we write them in a list with commas separating them and using curly brackets on the front and back. The fourth way to write domain and range is using set notation, and this is the more formal way. We use special symbols in this. We use our curly or squiggly brackets, as I like to call them. We use a special looking E, which means is an element of, and a line or a bar that means such that, just part of the formal notation. I also have written down here the different letters that represent the number systems. We mostly use the real numbers, so we'll mostly use R. Now let's look at these examples. If we have values of x that are less than or equal to 10 in the domain, then we always start with a squiggly bracket, state our variable for the domain, so usually x. Then we use the bar, that means such that. This first part here will always be written the same. Then you're going to have your inequality or the restrictions on the variable. So what conditions are the domain variables there? Then we have a comma, and then we write our x is an element of whichever number system, closing it off with a curly bracket. In the range, it starts off the exact same way, you'll see, except we use our variable that's in the range. And then we write our inequality that represents our y values that are included, a comma, and then y is an element of the real numbers, and then a curly bracket. Set notation is always written in the same pattern. You will always have a curly bracket to start, and then you'll have your variable, whether it's domain or range, you state your variable, and then such that your inequality, comma, and then your variable is an element of whichever number system, and then your curly bracket. Once you get the hang of the pattern in this notation and writing the inequalities, it's not as difficult as it seems like at first. Please see Part 2 of the video for the rest of the notation and examples.